of higher degree with modeling. Describe how to transform the graph of an appropriate monomial function, f of x equals x to the n, into the graph of the given polynomial function. We're not doing the sketch the graph part, but they move the same way that the parabolic functions do, so it follows the same stuff, other than it's raised to a higher power than that. So number 4, g of x is equal to 2/3 times x minus 3 cubed plus 1. So knowing that they follow the same stuff, what does that mean about these that are moving? Like how they're moving?
Like you shifted?
Anything that's a transformation.
Right 3,
Right 3. What else?
It's compressed.
Up 1 and compressed. Six. G of x is equal to 3 times x minus 1 to the 4th minus 2. What's happening to this one?
Right 1.
Right 1.
Down 2.
Down 2.
And stretched.
And stretched. And again, like none of these ones were negative, but if there was a negative in front, obviously it would still be reflected, just like the other problems we had been doing. All right, we're jumping like a pretty big chunk because it's all just like doing stuff on your calculator that we just don't need to worry about. And so we're looking at in behavior. So this is what happens as x gets really big or really small. So we'll be finding the limit as x approaches infinity of f of x and the limit as x approaches negative infinity of f of x. When we do this, all I care about is the highest powered term, okay? And if these are not going to be, but if it was a problem where it was like a rational function where it's like top and bottom, then we only care about the highest powered term on the top and the bottom. Everything else we just ignore because at infinity, at a really big number, everything else is just arbitrary. It doesn't mean anything. And the answer is going to be that it's either going to infinity or negative infinity. For the ones that we're doing when they're fractions, it's different. But for these ones, the answer is literally either infinity or negative infinity. So 26, f of x is equal to negative x cubed plus 7x squared minus 4x plus 3. So the first thing you should always do before you do anything with in behavior is make sure that your highest powered term is in front. If it's not, you don't need to like rewrite it unless it tells you to rewrite it in standard form. But I only care about that term. So if they're not in order, I might use the first term, and that's not really the highest powered term. So I like to like circle it or rewrite it just so that I can see what I'm using, because everything else is irrelevant at infinity or negative infinity. So I have the limit as x approaches infinity of f of x. I'm not going to rewrite the whole function. Or a lot of times what I will do is I'll just write of negative x cubed like that, so that I can just see like all I care about is that part. But that's really the technical notation would be of f of x or of the whole function written out. But I usually just write the one piece that I'm looking at so it's not confusing. So if I take a really big number, I like to do something dramatic like 500, and I plug it in here, and I have negative 500 cubed, what's going to happen to that number? So it's either going to positive infinity or negative infinity. So which one is this one going to be? Negative infinity. Then we do the limit as x approaches negative infinity of negative x cubed. So if I plug in negative 500 for x, what's going to happen? Where's it going?
Still no, positive.
Positive infinity, because negative 500 cubed is still going to be a negative really big number, and then times negative is going to be positive. Now, when you do this on the quiz or the test, you need to write this like I have it. Well, you can either write f of x or you can write out the whole thing. But you need to show that its limit as x approaches infinity. Do not, or negative infinity respectively. Do not assume that I'm going to just know if you write positive infinity and negative infinity for an answer that automatically I'm going to know what you're talking about. Okay, you need to make sure that you label them. Now, this is a cubic function, okay, or any odd function. They should be going in opposite directions, okay? An even function, they're both going to go the same direction, but you always should check both and make sure so that you ensure that you did it right. But a really easy way for me to check this is to say this one went negative, this one went positive. They're opposite. It's an odd function, so that makes sense, okay? 28. F of x is equal to x cubed minus x to the fourth plus 3x squared minus 2x plus 7. Yep, so this one's not written in order. They do this to throw you off. So I'm looking at negative x to the fourth. Again, if you want to rewrite it in order, you can. If you just want to circle it, just do something that makes sure that you don't look at that x cubed, because I can assure you you're going to end up with the wrong answer if you use x cubed instead of the negative x to the fourth. So I'm looking at the limit as x approaches infinity of negative x to the fourth. So if I plug in positive 500 to negative x to the fourth, where's this going to be going? Negative. It's 500 to the fourth is a really big number times a negative. So this is going to negative infinity. The limit as x approaches negative infinity of negative x to the fourth. So if I plug in negative 500 for x, what's going to happen?
It's the same thing.
Yep. Because a negative number raised to an even power becomes positive, and then it's times that negative that's out front, so negative infinity. So notice, this is an even function. They both go the same direction to finish. Questions on that? Because there's only 4 problems in end behavior. So
Do you have to answer it by saying it's even or odd or
no, it doesn't ask for that. That's just what I'm trying to tell you, my process of like how I think through it to make sure that my answer makes sense. All right, find the zeros of the function algebraically. So that means we're basically going to be factoring to find zeros. So we factor, set it equal to 0, and solve. So 34. Find the zeros of the function algebraically. F of x is equal to 3x squared plus 4x minus 4. So I need to factor this arch method. So 3 and negative 4, so I need factors of negative 12 that add up to equal positive 4. 6 and negative 2. So I've got 3x squared plus 6x minus 2x minus 4. And it doesn't matter if I do the 6x over here or the negative 2x over here and like swap them. It's going to give me the same final result. Now I factor by grouping. I'm going to take a 3x out of here, and that leaves me with x plus 2. In this one, I'm going to take out a negative 2. That leaves me with x plus 2. Reminder, these two things have to match. If they don't, something is wrong. So then I've got 3x minus 2 times x plus 2. You can always FOIL this back to check. Once I factored, I'm not done. I'm finding zeros. So I'm going to take each of these and set them equal to 0. So 3x minus 2 equals 0. And x plus 2 equals 0. So on this left one, I've got 3x equals 2. So x equals 2/3. If you can do that all in one step, obviously, you're welcome to do that. On the other one, subtract the 2, so x is equal to -2. So x is equal to -2 or x is equal to 2/3. Both of those would be zeros of this function. Now, what's true about the number of zeros with a function?
It should be the same as the highest power.
Yeah, it can have at most that many. And I say at most because we're going to be getting into some problems in a minute where you may not see all the zeros because you may have a non-real zero, which still counts as one of them. Or a zero might be a repeated zero and have like a multiplicity of a higher value. So you might only have 2 distinct zeros, but in total you may have 4 because of something being repeated.
An undefined x.
Well, a non-real number, like a I. Like this one is a squared function. Obviously, it has 2 zeros, right? But when we get to higher power ones, that's not always, you're not going to always see all, like on a function that's like, raised to the 4th. You're not going to always see all 4 zeros as we go. But you'll see what that looks like in a minute because we'll have a few of those. One more of these ones, though. 36, f of x is equal to x cubed minus 25x. So finding the zeros algebraically, any idea where I should start with one like this? Take an x out. So I would get x times x squared minus 25. Then what? It's a difference of squares. So I have x times x plus 5 times x minus 5. And then now set them each equal to 0. So x equals 0. X plus 5 equals 0, x minus 5 equals 0. So obviously x equals 0 is already good to go. And then x equals -5 or x equals +5. All right, questions on those? All right, so they're not going to have you do anything like bigger than that algebraically this way. That's in a later section. If you remember last year when we did the ones where we were finding like the last term over the first term and finding all the possible zeros, that's coming in a section or 2 of this chapter. But right now, if they're asking you to do it algebraically, it's something that can be factored. Or at least I'm pretty sure they're all just perfectly factorable and you don't need anything like the quadratic formula, but don't quote me on that 100%. I'll give you like a 95% sure that it's all factorable. All right, so the next ones are 39 through 42. They say to state the degree, list the zeros of the polynomial function, and state the multiplicity of each zero and whether the graph crosses the x-axis or at the corresponding x-intercept. We're not doing that last part. We're just doing the degree, zeros, and the multiplicity. Because you can all put them in a calculator and figure out the other part, but I'm not worried about that. We don't have to do that part. All right, so 40, f of x is equal to -x cubed times x minus 2. All right, so to find the degree, obviously I'm going to need to multiply this through so that I can see. I mean, you can probably visibly see it, but this is not a cubic function, right? Do we see that? Because this would be -x to the 4th plus 2x cubed, technically. So the degree of this function is 4. Huh?
Do we have to find the COV or
No. The zeros, we can find those by setting this equal to 0. So x is equal to 0, obviously, because negative x cubed equal to 0, if you want to be technical. So x is equal to 0. And then x minus 2 equals 0, so x equals 2. So my two zeros are x equals 0 and x equals 2. Now, I need the multiplicity of each of these, so I normally just write it like side by side like this, but like kind of do its own little column thing. But as long as it's clear like what it is. So the multiplicity is how many times that 0 occurs. So basically, how many powers is it raised to? So x equals 0, that 0 occurs 3 times because this x is raised to the third. So the multiplicity of that one is 3. The multiplicity of this one, obviously it's only occurring one time, is 1. So x equals 2 is 1 time, x equals 0 is 3.
So wait, why isn't one of them 4?
Because they add up to 4. So your multiplicity should add up to 4 at most. Again, I think these ones are all disregarding the possibility of a non-real 0, but because we can have non-real zeros.
So when we're finding the zeros, we can't just FOIL them
What do you
out,
mean?
or like factor them out. Like when we found the zeros for number 36, we just did like the FOIL stuff, whatever.
Yeah, well, we factored these, and then we set them each equal to 0. So each of these has a multiplicity of 1. This was a degree 3 polynomial. So if I was doing the same thing I'm doing down here, I would say this is degree 3. These are all my zeros, and they all have a multiplicity, I can't write, of 1.
Why is it 0 3 times? Because we just put 0 in for x cubed.
Because it's factored. This is like this because this is being multiplied by this. So this is what this function is.
Okay.
So in total, it can add up to this number, whatever the highest number is.
And what did the x minus 2?
This was the original problem. This is a totally different thing than what I was doing up here.
Okay.
It's a totally different question. 42, another one of these ones. F of x is equal to 7 times x minus 3 squared, and then times x plus 5 raised to the 4th. So is the 7 out front really doing anything for me? Nope. So again, I don't really want to have to sit here and multiply all of this through to figure out what the highest powered term is. So all I really need to do logically to think about this is if I multiplied x minus 3 times x minus 3, the highest power is going to be what?
Square. 2.
X squared. Okay? So just for the moment, just work with me. X squared is the highest powered term here. And I'm doing this because we're multiplying. Over here, x plus 5 times x plus 5 times x plus 5 times x plus 5. The highest powered term is going to be what? X to the 4th. So the highest powered term of each of these when multiplied by each other, because they're being multiplied, is what? X to the 6th. So I don't care about absolutely anything else about what this multiplies out to be other than the highest powered term. So that right there tells me that I'm a degree 6 polynomial. For the zeros, I'm ignoring everything that I just did there, and I'm setting this top equation equal to 0. If I do that, what happens to the 7?
0.
Yeah, it just goes away, disappears. So then I have x minus 3 squared equal to 0. And I have x plus 5 raised to the 4th equal to 0. So technically what I'm doing is I'm taking the square root of both sides, which just gives me 0. So I end up with x minus 3 equals 0. Then I can add the 3 over, so x equals 3. So the 1, 0 is x is equal to 3. Over here, the x plus 5 to the fourth, I'm technically taking the fourth root of both sides, which just leaves me with x plus 5 is equal to 0. Then I'm subtracting 5, so x equals negative 5. So my other 0 is x equals negative 5. Now, the multiplicity of each of these is determined by the power of that whole piece. Okay? So x minus 3 is being squared, so it has a multiplicity of 2. So then what's the multiplicity of x equal to negative 5?
4.
Yep. So it has a multiplicity of 4. So that's all that I'm looking for you to do on those problems. Again, the other stuff, you can put it in your calculator and graph it if you are so inclined to want to see if it crosses the x-axis at the corresponding x-intercept or not. All right, one more thing in this section is using only algebra, find the cubic function with the given zeros. Support, we don't need to do that part. You can check it by putting it in your calculator. So 54. So they've told us that it's a cubic function. And so they give us the zeros. -2, 3, and -5. Now, that means x equals each of these things. If I'm trying to find the cubic function, I'm undoing essentially what I did up here to find the zeros. So, this is, I like to look at it this way. Once you're familiar with it, you don't really have to do it like this, but I like to look at it like this and then move the pieces over. So that means my factor is x plus 2. This one is x minus 3. And this one is x plus 5. So now I can take each of these things that were set equal to 0 and multiply them, to find the whole function. So f of x is equal to x plus 2 times x minus 3 times x plus 5. And then we just multiply and FOIL. So I've got, if I do the first two, x squared minus 3x plus 2x, so minus x, and then minus 6 being multiplied by x plus 5. So that gives me x cubed plus 5x squared minus x squared minus 5x minus 6x minus 30. Combine like terms, x cubed plus 4x squared minus 11x minus 30. So that's all you're doing on those ones. Just multiplying it out. Now, I'm not going to do this whole one out, but I just want to set this one up for you so that you, just as a refresher. So 56, the zeros are 1 plus the square root of 2, and 1 minus the square root of 2. So one thing as a reminder, it most likely is in your notes for when you do the sections where you're like finding zeros. But if 1 plus the square root of 2 is a 0, 1 minus the square root of 2 has to be a 0. That was a rule, and it's the same thing that applies with i's. But for right now, obviously, they gave them to you, and you knew it was a cubic function. But if they only gave you one of them, say, like on the AP exam, and they told you it was a cubic function, it would hopefully be a cue of like, oh yeah, 1 minus the square root of 2 also has to be. So this particular problem is why I like to start out my problems set up this way, where I say, well, x is equal to 1, x is equal to 1 plus the square root of 2, and x is equal to 1 minus the square root of 2. Because when I move this stuff over to find my factors, I have x minus 1. Over here, I have to subtract both of these things, so x minus 1 minus the square root of 2, so that's a factor. And then over here, I'm subtracting 1 but adding the square root of 2, so it's x minus 1 plus the square root of 2. And then we would just take those at that point and multiply them out. Now, a lot of times I do things in sequence, like in order. However, these are essentially difference of squares, more or less. So they end up, stuff's going to cancel. So whenever I have something like this, I usually will start over here multiplying. So why don't, just as a refresher, because why not? And we have a little bit of time. Why don't you try to multiply this out and let's see what we get to as an end result. So take a second and do that and see what you get. When I'm done. All right, do we have an answer? Are we close?
I got an answer.
What'd you get?
X squared minus 2x minus 1.
Oh, finish the problem.
Oh, find the zeros.
No, they already gave you the zeros, but you need to, I don't think you multiplied by x minus 1.
Oh.
Because it has to be a cubic function. So I'm just going on a limb and assuming that that's what you didn't do.
I got x cubed minus 3x squared plus x plus 1. That's what I got.
We agree? Wonderful. We remember how to multiply. Yep, so when you do that, that's why I say it's not exactly a difference of squares, but like it kind of is, because a bunch of the stuff cancels out nicely for you. At least it gets rid of the, gets rid of the radicals for you. And so then it multiplies all the way out and gives you a nice function that's easier to deal with. Any questions on those? All right. So that was it. So your problems are 3, 5, 25, 27, 33, 35, 39, 41, 49, and 53.